Hello everyone, welcome to Ganit Academy. In this video, let us study about the different operations performed on the rational numbers. Here we will also see different properties of rational numbers. And in the class 7, you have studied about the properties of integers, right? You have also studied about addition, subtraction, multiplication, division of integers, and you have seen which properties satisfy which operations. So here also we will be studying the same thing, but that is for rational numbers. Okay, so first let us take addition. And you have studied about the additive inverse, right? And identity, that is additive identity, absolute value, that is when we are studying integers. So similarly here also additive inverse is nothing but when you are adding two numbers, if the sum comes out to be 0. Okay, if the sum comes out to be 0, then those two numbers are called additive inverses of each other. For example, a plus minus a, that is equal to 0. So what I will tell? Minus a is the additive inverse of plus a. Similarly, plus a is the additive inverse of minus a. So if I consider integer, I told 2 is the additive inverse of minus 2. Minus 2 is the additive inverse of 2. And in case of rational numbers, you can consider 2 by 3. This is the additive inverse of minus 2 by 3. And minus 2 by 3 is the additive inverse of 2 by 3. So because if I add 2 by 3 plus minus 2 by 3, what happens? You will be getting 0, right? You will be getting 0. The denominator is same. So I will take 3 common. Next you have 2, then plus minus 2. Now the numerator is 0 divided by 3. So 0 divided by anything, that will give you 0. Okay. So I can say minus 2 by 3 is the additive inverse of 2 by 3. Okay. Just you have to take the number as it is and just write the opposite sign. So if you are having plus, take it minus. If you are having minus, take it as plus. So that will give you the additive inverse. Okay. So here if I take addition, so addition of two rational numbers, let us see that. So now I will take one number as 2 by 3. Another number I will take it as 3 by 4. Okay, 2 by 3 and 3 by 4. And let us add this. 2 by 3 plus 3 by 4. So now the denominator is different. So you cannot add 2 plus 3 5, 3 plus 4 7. You cannot do that. You have to take the LCM. And you know how to find the LCM, right? So what I will do? 3 and 4. Okay. And what happens? This does not have the common divisors. So what I will do? 3 and 1. So this is 4. And 4 and we have 1. So 3 into 4, that is 12. So I can multiply these two also. 3 into 4, take it as 12. Okay. Now we have to multiply. Okay. Multiply this denominator in this part. Because here if I want to make it 12, I have to multiply it by 4. Right? If I want to make it as 12, if I multiply 4, then only I will get 12. Here if I want to make it as 12, I have to multiply it by 3. So I cannot multiply only denominator. So along with that I have to multiply numerator also. So into 4 and here it is into 3. Same thing I am going to multiply. See, into 4 by 4. 4 by 4 is 1. So it does not make any difference to the number. 3 by 4. Here it is 3 by 3. So now 3 into 4 is 12. 2 into 4 is 8. 3 3s are 9. 4 3s are 12. So now the denominator is same. So I can take 12 common and here it is 8 plus 9. So this is nothing but 17 divided by 12. So the answer is 17 divided by 12. And another thing, another shortcut is, see, 2 by 3 plus 3 divided by 4. So take this, multiply and write it. 3 into 4, 12. Now just cross multiply. 2 4s are 8 plus 3 3s are 9. So 17 divided by 12. Okay. Is this a rational number? Is 17 by 12 a rational number? Yes, it is a rational number. It is a rational number. Next, let us take 2 by 3 and then let us take minus 3 by 4. I am considering one negative and another one as positive. So now if I add these two, 2 by 3 plus minus 3 divided by 4. Okay. So here also once again 3 4s are 12. Then you have 2 4s are 8 plus 3 3s are 9. But remember there is a minus sign. So it is minus 9. So here what happens? You can say this is the addition of two integers with different signs. So we have already studied the technique. When it has different signs, you have to take the difference. So 8 and 9 difference is 1. So write it as it is 1 divided by 2, 12. And what is the sign which is associated with 1? It is the sign which is associated with the number which has greatest absolute value. You have already studied about the absolute value also. So what is this absolute value? It is a positive number. So if I take this modulus of minus 9, okay, this is nothing but it is two vertical lines and you have to place the number inside it. So to find the absolute value, this is also called as modulus, mod. Okay. So what will be that? You have to take the number as it is, but the sign it will be ignored. You are going to get a positive number. Even if it is plus 9, you are going to get it as 9. Even if it is minus 9, this is 9. So absolute value, it just tells us the distance of that particular number from 0 on the number line. Okay, what is the distance? So for example, if I consider minus 2, it is 2 units from 0. 2 units from 0, right? So that is your absolute value. So here the absolute value of minus 9 is 9 and 9 is greater than 8. You know, right? So what is the sign which is associated with the greatest absolute value? That is a negative sign. So I am taking the negative sign here in the numerator. So minus 1 divided by 12. So is it a rational number? Yes, it is a rational number. It is a rational number. Now let us take by 3 and minus 3 by 4. So what happens when we add these two rational numbers? So minus 2 by 3 plus minus 3 by 4. Once again, we have to take the LCM. So that is 12. Cross multiply this. So 4 into 2 is 8 and it is plus into minus is minus. Again it is plus. Cross multiply. 3 3s are 9. Plus into minus is minus. So now in the numerator we have two integers which are having same sign. So when they are having same sign, you have to take the sum of the absolute values. Absolute value of minus 8 is 8 and absolute value of minus 9 is 9. So 8 plus 9, that gives you 17. So what is the sign which is associated with 17? So that is the sign which is common to both the integers. So here the sign common to both the integers is minus. So it gives you minus 17 by 12. So this is also a rational number. So we can say that the rational numbers, these are closed under addition. Rational numbers are closed under addition. So this is the closure property. Okay, so this is the first one, closure property. You know, whole numbers, integers, these are also closed under addition, right? Similarly, rational numbers are also closed under addition. So let us take the commutative property. what do you know about commutative property? That is, if A and B are two rational numbers, then A plus B should be equal to B plus A. Then only we can say that the addition is commutative for rational numbers. So let us take the example. So 2 by 3 plus B is 3 by 4, and here it should be equal to 3 by 4 plus 2 by 3. So now once again I will take the LCM. 3 into 4 12, cross multiply, 2 4s are 8, 3 3s are 9. So this is 17 by 12. Now I have changed the order of rational numbers. Order, that means I have taken 3 by 4 first, and next I am taking 2 by 3. So again it is 12, cross multiply, 3 3s are 9, 4 2s are 8. This is also 17 by 12. So 17 by 12 is equal to 17 by 12. That means LHS is equal to RHS. So what happens? This commutative property is satisfying here, right? So let us take one negative rational number, another one is a positive. So let us take 2 by 3 plus, let me take different number now. I will take 5 by 4. 5 by 4. Okay, that is negative. So it should be equal to minus 5 by 4 plus 2 by 3. So now what I will do? I will take the LCM. 3 4s are 12. Cross multiply, 2 4s are 8 plus 3 5s are 15. But it is plus into minus, it is minus. So 8 and minus 15, it will give you minus 7. Minus 7, because larger absolute value is 15. Sign associated with 15 is minus. So the sum gets minus sign. Okay, that is minus 7 divided by 12. Here also 3 4s are 12. Minus 5 into 3 minus 15. 4 2s are 8. This is also minus 7 by 12. So LHS is equal to RHS. So we can say the addition is commutative. Addition is commutative for rational numbers. And we have also seen that addition was commutative for whole numbers. It was also commutative for integers. Similarly, addition is commutative for rational numbers also. Now let us take associative property. What does this associative property states? It states that A plus B plus C, that should be equal to A plus B plus C. So from commutative property, what I can conclude? That the order of addition does not matter. So you can change the order of these rational numbers and you can add it. So here associative property, first I am grouping B plus C. I will add this, then I will add with A. First I will group A plus B, then I will add with the C. Okay, that means the grouping is different in associative property. So let us take three different rational numbers now. So 2 by 3, 3 by 4, 4 by 5. Okay, so let us take these three numbers. Now 2 by 3 plus 3 by 4 plus 4 by 5. That should be equal to 2 by 3 plus 3 by 4 plus 4 by 5. So here I am grouping this. So you know, according to BODMAS, first we have to solve whatever inside the brackets. So here I will solve this first. Okay, first step I will solve this. So what is the LCM of 4 and 5? It is 20, right? Or you can multiply these two. 4 into 5, 20. Now you have to cross multiply. So 3 5s are 15 and then 4 and 4, it is 16. So what is 15 and 16? That is 31, right? It is 31 divided by 20. That should be added with 2 by 3 now, right? 2 by 3. So now there is no common divisor. So now what I will take? No common factor. So I will take the LCM again. 20 into 3, that gives you 60. So again cross multiply. 2 into 20 is 40. 3 into 31, that is 93. 93. So what does this give? 40 plus 93, that will give you 133 divided by 60. Right? Okay. So now let us see this. 3 4s are 12 and again it is cross multiplying. 2 4 8, 3 3s are 9. Then it should be added with 4 by 5. So this 8 plus 9 is 17. So 17 divided by 12 plus 4 divided by 5. And you know the LCM of 12 and 5, that is 60. 12 into 5 is 60. Then cross multiply. 17 into 5, that gives you 85. 85. And 12 into 4, that gives you 48. So now when you add these two, you will be getting 133. 133 divided by 60. So this LHS is 133 by 60. RHS is also 133 by 60. So LHS is equal to RHS. So associative property holds good, right? Similarly, take negative and positive rational numbers. So let me take 2 by 5 minus 3 by 5 and you will take 4 by 5 minus 4 by 5. So now let us add this. 2 by 5 plus minus 3 by 5 plus minus 4 by 5. That is equal to 2 by 5 plus minus 3 by 5. Then you will be adding it with minus 4 by 5. So as it is I am writing. I am taking the brackets also as it is. Okay. So now I will solve this bracket. So LCM will be 5 because common is 5. You know how to take the LCM. So I will take 5, 1 and 1. So it is 5. LCM is 5. And we will be adding the numerator because we are not cross multiplying because both have same factor, that is 5. So minus 3 plus minus 4. So adding two integers which are having same signs. So 3 and 4 7, sign which is common to both the numbers. Next 2 by 5. Here also LCM is 5. Then you will take 2 plus minus 7. So that will give you minus 5. So this is minus 1. Here if I take 2 and minus 3, that is minus 1 by 5 plus minus 4 by 5. Again LCM is 5 and adding minus 1 and minus 4, it gives you minus 5. So this is equal to minus 1. So minus 1 is equal to minus 1. So we can say addition is associative for rational numbers. Addition is associative for rational numbers. So what did this addition satisfy? Closure, commutative property, associative property. So this is similar to integers, right? In integers also this was satisfying all these properties, and for rational numbers also these three properties are satisfied for addition. In next video we will be studying about the multiplication of rational numbers.